Thank you very much, Knime, for the opportunity to be here. Today, we are proud to present our advanced analytic product, Guided Data Wrangling. Guided Data Wrangling is a product from a set of test systems. So first, let's look into its sort of group and its sort of test system, what they do. Its sort of group is a global technology company supplying systems for passenger cars, industrial technology, and commercial vehicles. It sort of enables vehicle to see, think, and act. And it allows it enables next generation of mobility. It's, as you can see here, its sort of products are almost everywhere, and this is not even our full portfolio. Its sort of test systems, as the name suggests, develops and produces test benches for on and off-road mobility, like electric engines, axle drives, transmissions, battery, brakes, etc. And myself, Nithin Thomas, it is already introduced me. I'm a data scientist working in automotive industry for the last 5 years, and co-product owner of Guided Data Wrangling. Now, the mandatory introduction part is out of my way. Let's talk about the product. Why did we develop Guided Data Wrangling? It's a tough group, as most of you here, in its journey to digital transformation. And Guided Data Wrangling is a stepping stone in this journey. Digitalization propels data analytics. And data analytics can give huge value from digitalization. But to achieve the most out of it, to get the full potential of data analytics, we need to decentralize it. In other words, data analytics shouldn't be something that is done by only one centralized department. We have to democratize analytics. We want to unlock the possibilities of self-service advanced analytics for production and quality specialists and create an upskilling path for them from descriptive statistics to advanced analytics. And we believe Guided Data Wrangling is the key to achieve this. At this point, I want to hand over the presentation to Dr. Maria Kaiser, and Maria will move us forward.
Thank you very much, Nithin. Hello from my side. My name is Maria Kaiser, and I'm a senior data scientist at thaltegos, and I'm the co-product owner of the product Guided Data Wrangling. thaltegos is a management consultancy that guides organizations on the way to become data-driven by developing and implementing strategy and use cases up to operational application. We are achieving higher impact through deeper insights which are based on data. The ZF Group invests several billion euros over the next years in digital transformation. The key aspect of digital transformation is leveraging the value of their data across all disciplines and divisions by providing data-based solutions. We are very happy and proud to develop Guided Data Wrangling together with our partners at ZF to enable test engineers to base their decisions in the future on data. Now let me demonstrate a use case to you from our production, which perfectly shows the need for Guided Data Wrangling. We have Stefan, who is a test engineer, and he has some problems with his production. He needs to analyze production failures. Product and quality engineers like Stefan ensure our product quality and also the customer satisfaction. Thanks to digitalization, Stefan now has more data available than ever. However, this data he has is production data, and it comes from different sources, is in different structures, has varying quality. In other words, it's quite messy. And this production data varies a lot and is hard to compare also across different product value chains. This means the preparation of this production data is of great effort, especially if you're not a data scientist like our test engineer Stefan. But still, he needs to provide reliable results fast to his customers. Formerly, Stefan needed to apply several different tools to just load the data, to merge it, to visualize it, and analyze it. But luckily, Stefan now has guided data wrangling at hand. What is guided data wrangling? Guided data wrangling is a reusable data science toolbox, which is tailored to the discrete manufacturing industry in the automotive industry. We are providing our customers a library of components which help them preparing their production data to start with standard and advanced analytics. Now, I want to show you how Stefan goes forward with guided data wrangling and his problem. So here you see the workflow Stefan created. He knows that end-of-line measurement 1 is causing the production failure. And now he wants to find out how earlier production steps might affect this faulty measurement. Therefore, he loads assembly and end-of-line data into Knime and joins it together based on the serial number. To ensure flawless functionality of our guided data wrangling components, he converts the data set using a component of us into a generic data structure. In the next step, he uses a component called amount of data that helps him have a look into his data set he just created. Here he can check how much data is inside, so what is the total number of parts tested, how many test runs are included in the data set, is enough data inside, also the calendar week he's interested in, or the material he's interested in. After he checked that, he's undertaking some data cleaning steps and then taking a subsample of this huge data set. Therefore, he uses another component which helps him taking a subsample based on his domain knowledge. After selecting the subsample, he's doing another test with a jump detection component. Here he unfortunately finds out that there are still some jumps in the data set, and he's doing another quality control using our normality test component. Here he can easily see that there is still measurement inside which is not normally distributed. This is kind of a problem because he wants his analysis to be valid. Therefore, he does another round of data cleaning to get rid of these measurements and then goes to his last step. Here he uses our correlation matrix plot component because he's interested to see this faulty end-of-line measurement 1 to which other assembly steps is it correlated to. And here in the scatter plot matrix, he can easily identify that there are 4 highly correlated assembly steps before. Now that Stefan knows what prior assembly steps might be affecting the faulty end-of-line measurement, he contacts the process manager to agree on next analysis steps. Let me shortly recap how guided data wrangling helped Stefan as a data science beginner. So first of all, our library and example workflows give him guidance and also inspiration what to do, where to start. Then, of course, these specific components help doing manufacturing-specific analysis. And thanks to our standardized data structure, we always guarantee that our components also work. On top of that, this is, of course, Knime-specific. The components are reusable. And the big plus is the tailored visualizations that you just saw. So those visualizations really help to get the best out of your analysis. And now I hand back over to Nithin so that he can tell more about Stefan's journey.
So we saw the benefits of data wrangling, especially for a Knime beginners. Many of you are already using Knime, maybe for years, and he created multiple solutions with Knime. So what value would Knime bring to you as an advanced user? There is one more step Stefan or any other citizen data scientist can take to get best out of their analysis: solution deployment. When we talk about solution deployment, we have heard from one side or another that only 1 in 10 solution reach deployment, or only less than 20% a solution reach the production stage. So how guided data wrangling, a product based on Knime, can help in this situation? So after identifying the reasons for the failure, Stefan wants to detect them as early as possible. So let's assume here Stefan is an advanced user, and he knows that assembly gives a hint to the production failures. So he can detect the failures as early as possible if he create and deploy a solution to detect the outliers or the jumps in the assembly area data. So let's see how Stefan will create such a solution. Here, Stefan first using a database loader component to load the data from a database. It is worth noticing that he used a Knime configuration reader first, which will make the maintenance easier in later stage. Once the data is loaded, next step is to convert them to a generic data structure. Maria already introduced the concept, which makes the solution reusable and the seamless execution of other data wrangling components. Once the data in generic data structure, now the next step is to detect the outliers. And there's no surprise here, Stefan will use a outlier detection component to do so. And he makes some project-based changes in between that it will fit directly to his use case. And once it's set and check the testing, or execute for at least once, Stefan now wants to create a notification. So it can send a notification whenever there is an outlier. But before that, Stefan would like to write the result into a data lake, because this ensures the traceability of the solution. And also, the data will be a place that is more available for analysis. So here, Stefan is using send email component to send the notification, and workflow is ready to deploy. Here you can see the blue annotation is data wrangling components, and the gray ones are the project integration. Here now, Stefan is uploading and scheduling the solution. You might have noticed that there was no single change Stefan did to make it work in the server or in the analytic platform. He can directly deploy it. And in Knime, you are already seen it's very easy to upload a workflow, schedule a workflow. It is very easy. It is as easy as it's possible anywhere. Once he schedule it, he's now scheduling for executed from 11 o'clock and every half an hour. Once it starts to execute, once they detect the outliers, it will send a notification via email. And in this notification, the receiver or the recipient can understand, okay, which parts are getting outliers or some other information, and a link to a visualization. So all the changes in the assembly, on the production, is not necessarily a outliers or something wrong with it. Sometimes they do these changes, and sometimes these changes are unintended. So in this visualization, the recipient's shift leader, whoever it is, can validate this. Okay, now at 9 o'clock in the evening, there was a distribution change. And if it is not intended to happen, then they can easily say that, okay, this is something is going not correct there. We should look into it, and then they can avoid production failure later. Yeah. So we have seen all the deployment-related complications where already taken care of in the data wrangling components. So let's explore some of other functionalities of data wrangling components. All components are developed in a way that it is executable in analytic platform, server, including web portal, without a single change. Intelligent handling of flow variables helps to hide the technical challenges to make the components deployment ready. Dynamic configuration of the components achieved by using configuration files instead of using the manual configuration in the workflow itself. In this way, we can easily change parameters of the workflow. For example, changing from test environment to production environment. And the users can control the behavior or change the behavior of the workflow without touching the workflow itself. All components are well tested and well documented, and numerous examples are available for the users. Guided data wrangling comes with a readiness check workflow. This is a workflow that will automatically prepare user environment to use data wrangling components, and also it can be used to make sure that user development environment is compatible with the production environment. We have an active community of developers and users of data wrangling. And licensed users can request for new components and new features and directly interact with the developers to clarify questions. And of course, all components are well maintained. We are regularly updating existing components with the new features and bug fixes, also testing components with the new Knime releases. We are developing and releasing new components regularly. As you can see here, our components are distributed across 6 categories. You might have already noticed the similarity between this and CRISP-DM model, an industry standard for data science solutions. We have a great number of components in data preparation, data understanding, and data access. And in the coming iterations, we are working on more components to enable state-of-the-art versioning with advanced analytics development in Knime. Here are some feedbacks we received from our users. A quality lead from Spain said that Knime plus data wrangling are Lego bricks to build small church or a huge Gothic cathedral. Quality engineers to management in digitalization are really happy with the product. If you have any questions, you can contact us. thaltegos and Stuff Systems are partner with Knime, so we can get more information from our partner websites. And thaltegos has a booth here, so if you have time, please stop by. And that brings us to the end. I would like to thank you for your time and attention, and that too close to the lunch. Thank you very much, everyone. Guided data wrangling, your key to unlock production data treasure chest.
Thank you for this great presentation. So we have a little bit time left for questions, and I give you a little bit time to think about your questions, because I have one. How many of these components are there out now?
It's currently around 35, and it will reach 40 in a few weeks.
Did you also consider building your own Knime nodes?
With the new changes in Knime, with the Python nodes and all, yeah, this might be something we will look into future.
Very nice. Yeah, I love how you just build workflows with components. Stefan's life got so much easier.